The second descriptive statistic that we are going to look at is the concept of variation. With variation, we're looking at how much does the data vary? And so we have three different measures that we use to describe that. The first measure is the easiest, and it is the range. So the range is just the difference between the maximum and the minimum data values. Obviously, if we're using the largest and the smallest, it's very sensitive to outliers because your outliers would be your largest and smallest pieces of data. Because of that sensitivity to outliers, it is not very useful. So easy to do, but not used very often at all. Let's take a look at data. I'm using the same nurses data, but I've used a smaller data set because some of these calculations are quite involved. So in order to find range, I'm just going to take the largest piece of data, which here is the number of nurses in Delaware per 100,000 residents, and subtract the smallest piece of data, which is the number of nurses in New York. And I get 307 nurses, and that would be per 100,000 residents, and we had that information in the previous slideshow. So our next measure is called standard deviation, and this measures how much each particular data value deviates or varies from the mean, and it really calculates the average amount of variance from the mean. So instead of just looking at largest and smallest, it's comparing everything to the mean as a measure of center. Of all of the different measures of variation, this one is the most commonly used. If we would get a value of 0, that would mean that there is no variation. All of our data values are exactly the same. And so the mean and all of the data values would be equal. From this, we understand that if we get a larger number, that means there is more variation. And if we get a smaller number, there would be less variation. And just like when we were working with mean, we have two formulas. So our first formula has the English letter here, S, and so that is for a sample. And our second formula has the Greek letter sigma, and that is the formula for the population. Formulas are essentially the same, they're just using a few different letters. So we see this uppercase sigma, we're going to add up, and we're going to add up these answers. So in here we have x, our piece of data, subtract x bar, the mean, square those, then add them up, divide by n minus 1, and we remember is the number of pieces of data in our set. Same concept over here for the population. X is the data, mu is the mean, subtract them, square them, add them up, and capital N is the number of pieces of data in the entire population. So both formulas doing essentially the same thing, just the differences in the notation. So let's look at our set of data, and this formula is complicated. That's why I narrowed our data set down to such a small set of data. So in order to do this formula, I gave us a chart to help us organize everything. First thing that we're going to need is to actually find the mean. So what I have to do to find the mean is to add up all the data values. So I'm going to my calculator, 848 plus 858 plus 1155 plus 906 plus 1030. And when I do that, I ended up with 4,797. And I'm going to take that and divide it by 5, because there are 5 pieces of data. And that gave me a value of 959.4. So that's my calculation for x bar, the mean of this small sample. So I'm going to fill that in here. So my mean, 959.4. My n value, and I remember it's just the number of pieces of data, is 5. Now I'm going to come down here to my table. The first column is x. X we know represents our pieces of data, so I'm just going to fill in the pieces of data from our set. Next I want to do the differences, because order of operations tells me to work inside the parentheses. So inside the parentheses I'm to take each piece of data and subtract the mean. So I'll write out the math for the first one, and then I'll just do the math on my calculator from there. So the piece of data is 848. I'm subtracting the mean. The mean is the 959.4. And I actually want to record my answer, and my answer here is negative 111.4. And then I'm going to repeat that. So I'll do 858, subtract the mean, and from that I get negative 101.4. And I repeat. So 1155 minus the mean, and I get 195.6. 906 minus the mean, I get negative 53.4. And 1030 minus the mean, I get positive 70.6. So I come to my next column. My next column is this answer that I had, that's what's in parentheses, and squaring it. Now, because there are parentheses in the problem, when I'm doing this on the calculator, I want to type the parentheses. And I know that when I square a negative times a negative is a positive. So if you type in the parentheses, your calculator will give you the positive. If you don't, your calculator thinks you don't want the positive and it would give you a negative. But all of these, always positive. So negative 111.4, squaring that on my calculator or multiplying it by itself. I'm getting big numbers here. So 12,409.96. And I repeat that. So now I'm going to take negative 101.4 times itself, square it, and again I should get a positive answer. And I continue down the column, so this time I'm going to take 195.6 and square that. I'm going to square the negative 53.4, and I'm going to square the 70.6. Next, as I look at my formula, I've taken each value, subtracted the mean, and squared the answer. I'm supposed to add them all up. So on my calculator, I'm going to take this whole column, add them all up, put my answer here at the bottom. Be careful typing them into your calculator. I like to double check my math when I'm doing this by hand. And I get 68,787.2. Now this number goes into the formula as the answer for this entire top part where I have taken the sum of all of these. On the bottom of this, I take n, which I had written n up here at the beginning as 5. So I take n as 5 and subtract 1, so 5 minus 1 is 4. Now on your calculator, most of you should be able to type the square root symbol first and then put all this in, but it'll vary by calculator. Order of operations says we would do this division and then take the square root of that. And so when I put that in my calculator, I get 131, and then there's a long decimal. We're using the same rounding we did with the mean, so I'll take one more digit, and so 131.1. And this would be nurses per 100,000 residents. So it's that exact same label that we had with all of our measures of center and that we have again with this measure of variation. Our final measure of variation is variance. And this one is equal to the standard deviation squared. So again, tons of math. We have to do the whole standard deviation calculation we just did on the previous slide and then square our answer. And so again, two symbols. Sample variance is S for sample standard deviation squared. Population variance is lowercase sigma squared. Since the variance is squared, the label is then squared. So this presents a unique challenge. So here was our data. And there was our standard deviation, 131.1. Square that, and I have 17,187.2 nurses squared. Or square nurses. Never seen any square nurses. So the challenge with variance is that square label doesn't always make sense, not always realistic, and because of that label being squared, we do not end up using variance nearly as often and will not use it a lot in this course. It does have some value in statistics as a whole, and that's why we even talk about it, but we will focus on standard deviation in this course. So let's take a look at technology. We did a very small data set, 5 pieces of data, and it took us like 10 minutes to do standard deviation. So we really want to use technology, especially as we work with larger data sets. So again, I am in Minitab. In Minitab, the first thing I'm going to do is just check our work on the data we did. So we had done the states that border Pennsylvania, including Pennsylvania itself. And this is the descriptive statistics. So I'll go to Statistic, Basic Statistics, Display Descriptive Statistics. The data we want here is in Nurses 2, so double click on that. And the statistics we want. Well, previously we've learned the mean, the median, and the mode. Now, what we want to add is the standard deviation. We've also learned the variance, so we can add that as well. We have here the minimum and maximum, so we could easily calculate range, but it is even an option for Minitab to do that for us. So we'll click OK again. So in Minitab, we see the mean, which we had calculated as 959.4, so that matched our calculation. We see the standard deviation as 131.1, which again we had calculated and matched our calculation. We see the variance as 17,196.8. That's slightly different than the variance that we calculated. That difference is because we used our rounded off standard deviation to calculate variance, whereas Minitab is more precise and doesn't round in the middle of that process. And way back here we see the range as 307, which we had found as well. We see there is no mode. We could easily identify that by looking at our data, and Minitab calculated the minimum and the maximum for us, so we could use them to find the mid-range. It also calculated the median for us, and we had not done all those measures of center. Now, just for practice, we're also going to do a larger set of data. I would hate to have to do standard deviation by hand for the set of 51 pieces of data, because first I'd have to type in all 51 to find the mean, then I'd have to subtract for all 51 pieces of data, then I would have to square each of those. Lots of room for error. So we really want to be able to use Minitab to do the work for us. So again, we'll go to Stat, Basic Stat, Display Descriptive Statistics. Our column is nurses. The statistics we want, we don't have to change. So we'll click OK and click OK again. So we find our mean for the total data set, which we had seen in the measures of center video. We find our standard deviation for the total data set, and we didn't have to do the math for that, so really nice. The variance is given. The variance is a huge number because it's squaring the standard deviation. And again, thankfully, we didn't have to do the math for that. The range is given. The range is really large, 898. The range is not as useful because it is subject to outliers. So if there is a really high or a really low data value, that plays into the range. And we talked about that the variance is not as useful because of its label in square nurses. Hopefully you find using technology helpful. If the data is not pre-typed for you, you can always enter the data in the lower portion. If you type in your data, Minitab can then take care of all of the calculations for you, saving you a lot of time and reducing the number of errors.